Hello everyone, we're from Group Starlight. I am Aina.
I am Damia.
And I am Ainul.
False position method is used for finding the roots of nonlinear equation. So let's begin with creating headers for the tables. A is lower boundary input value and B is higher boundary input value. C is midpoint value, which will be found based on our A and B value. Functions of A, B and C will be found using function roots that we are solving for. We need two columns that determine which two outputs that gives negative values and tell us which direction to move, either left or right. So to accomplish this, we have to create an if-or statement which states that if function of A times function of C or function of B times function of C, and just note that the syntax here is less than 0, we print true if there is at least one root present, or if it is false, we print that.
We need to calculate the error, which is simply by higher boundary minus low boundary. For the first iteration, we need to assign A and B values based on the value positive or negative product test that we performed in previous iteration. To accomplish this, we are going to use a simple if statement using the equation provided in the video. Next, we have to create small steps in the x direction. So we put here 0.01 and we will go from our initial bounds of 0 until 1. Then beside this, we can apply this input to our function and get the outputs. Next, we can graph the function and visually see that we do indeed have a root between this point 0 and 1.
Next, if function of C times function of A is less than 0, if true, that means our root is to the left of our midpoint and it will remain unchanged, whereas B will take on the midpoint value. If false, the root is to the right of midpoint and it will take on the midpoint C value. We repeat the same formula for our higher root boundary B and bring down all other rows until iteration 4. One addition thing that is cool to add is a validation that we have a root within our two boundaries. Next, let's just create line in our graph to show where our current iteration of the false position method places us in relation to our root. We have just completed a problem using the false position method in Microsoft Excel. Phew, there you go.
We're done with this.
Don't forget to like, share and subscribe.